Hi, I'm Rob, and I'd like to welcome you to this video on loading, cleansing, and persisting data using NumPy, Pandas, and the MySQL connector for Python in the Python for Data Science and Machine Learning playlist on the Cumulus Cycles channel. Before we get started, I want to mention that this video assumes you have exposure to working with Python, NumPy, and Pandas. If you need a refresher, I have videos in this playlist that will get you started. And since this video also shows interaction with a MySQL database, I'll assume you have MySQL installed on your machine and are comfortable running the server. Okay, with all that out of the way, let's get started. Alright, we're in the Jupyter Notebook, and before we run any code in the cells, make sure you install the appropriate libraries if you haven't done so already. Now I'll go ahead and execute the code in the cell to do the imports. Now before we actually load the data, let's jump into the CSV. And we see we have several rows and several columns with mixed data types. Now back in the code, you'll see I have a variable that points to the path to the CSV file, and then a Boolean variable set to true, which is used to indicate whether we want to load the data using Pandas or NumPy. Now in this example, I'll load it with Pandas, but I included code for NumPy in case you're interested. Now, one thing I want to mention that I'm importing this data using the genFromText method on NumPy and not loadText, as we have mixed values and data types in the CSV. And genFromText is more robust, so it can handle that kind of data. So here, data array is a NumPy array populated from the data in the CSV file. Once it's loaded, we want to pass that data array to the Pandas data frame method to populate the df variable with the data in a data frame. Also, when the data is loaded by NumPy, it removes the dashes in the names of the column headers, as you see here. So you'll have to rename them back to their original naming so it will work with the rest of the code below, which is written to work with importing using the Pandas read CSV method. So I'll scroll down and execute the code in this cell. And here we see that we loaded the raw data from the CSV into the Pandas data frame. Its type is a Pandas data frame. It has 205 rows with 26 columns. Okay, now that we have the data loaded into a data frame, we could start doing some cleansing of the data. And I'm going to start with the column headings. First, I'm going to drop the columns that I'm not interested in. So if we go back into the CSV, there's some columns like symboling, normalized losses, number of doors that I no longer want in my data set. So here I've created a variable which is a list of the column names that I want to drop. Then I'll call drop on the data frame, passing that list to the columns property and doing an in-place drop. Of course, before I do the drop, I'll print the number of columns, and then after to see the difference. Then I'll call string replace on the columns in the data frame, replacing the dashes in the column names with underscores, and then print the updated column names. And finally, for the horsepower and peak RPM columns, which we see here, I'll rename those to HP and RPM respectively, and then once again print the list of column names. So let's go ahead and execute the code in this cell. And here we see our column names before dropping, where we have symboling, normalized losses, number of doors, and body style. And after dropping, the columns start with make, fuel type, aspiration, which we see here. After updating the column names, we've replaced the dashes with underscores. And I've renamed the horsepower and peak RPM columns to HP and RPM. Now let's print some info in the head on the data frame. We see we still have 205 rows, and now we're down to 14 columns. And here are the first 5 rows showing the updated column names. Now let's work on cleansing the data. First, I want to drop any rows in the data frame that are completely empty. So I'll call drop NA on the data frame, specifying how equals all, looking for rows that have all cells that are empty. Then there are some cells in the data frame that have a question mark in them. So I'll replace them with not a number. And any cells in the remaining rows that are empty, I'll also replace with not a number. Then I'll drop all the rows that have any cells that are equal to NaN. The engine type column has some cells with a single L in them, which I'll also drop. And here I'll look for any rows that are duplicates and drop the duplicate row. So let's go ahead and execute the code in this cell. And we see that before we dropped the rows that were empty, we had 205, and after we had 200. Before dropping rows with not a number, we had 200, which matches our ending number here. And after dropping the rows with NaN, we have 182. We started with 182 before we dropped the rows with engine type equal to L, and 171 after. And here we see we had no duplicates in the data set. Now let's call info and describe on the data frame. Here we see our 171 records, our 14 columns, and summary statistics on the data in the data frame. Next, I want to change some of the data types of the data in the data frame. For instance, curb weight is a data type of float 64, but it really has whole numbers. So I want to change its data type to integer. For bore and stroke, I want to change to float. Right now they're objects, which are represented as strings in the data frame. And horsepower, RPM, and price, I also want to change to int, which are currently objects. So let's go ahead and run the code in this cell, and then display info, head, and describe. And now we see curb weight is a data type of int64, bore and stroke are floats, and horsepower, RPM, and price are integers. Here are the first 5 rows, and again, summary statistics. Now, because models work best with numerical data, I want to change the categorical columns, which have strings, such as make, fuel type, and aspiration, to numerical values. So first, let's go ahead and get a list of the columns that have a data type of object, which again are represented as strings in the data. Then I'll create a new data frame containing those categorical columns. Then we'll print head, and then for each of those categorical columns in the data frame, we'll print the unique values in each column. So let's run this code, and we see the columns in the data frame that have categorical values are make, fuel type, aspiration, and so on. In the make column, we have Alfa Romeo, Audi, BMW, Chevrolet. Here's the rest of the list. Fuel type has 2 values, gas and diesel. Aspiration also has 2 values, standard and turbo. And you can see the rest of the categorical data for these columns. Now, to deal with the number of cylinders column that currently has categorical values of the strings 4, 5, 6, 8, and 12, I'm creating a mapping that I'll use to convert those strings into the numerical representation of that value. So this line of code will do that replacement using the cylinder mapping variable. Then once the values are updated, I want to change the data type of the number of cylinder columns from object to int. So let's go ahead and execute this code and see the result. And if we look at the number of cylinders column, we'll see it's an int, and the values in the cells have been replaced with numbers. Next, I want to use the label encoder, which we imported from sklearn, to label encode the categorical make, fuel type, and aspiration columns from objects to integers. So let's go ahead and run the code in the cell and the tail. And if we scroll back up for a second, we'll see that the values for make used to be strings such as Alfa Romeo and Audi. Fuel type had, for example, gas, and aspiration had, for example, standard. If we scroll back down, we see that the make, fuel type, and aspiration columns are now integer values. So for each unique value in the make column, it has been assigned an integer, starting at 0 and incrementing by 1 for each unique value. The fuel type has gas or diesel, so those values are 0 and 1. And aspiration has standard or turbo, and again, those values are 0 and 1. Next, we'll one-hot encode the engine type and fuel system, where we see that the values in the engine type column consist of dual overhead cams, and rotor. And we have several values for fuel system. So if we go ahead and use one hot encoding on these columns, we now see for each type of engine type, we have an entry with a numerical value, where the specific engine type in each row will have a 1, and the other engine types will have zeros, and the same for fuel system. So what I want to do now is check for any remaining categorical columns in the categorical data frame, and I'll put them in this variable and then print it, as well as check for any remaining categorical columns in the original data frame and print those. So let's go ahead and execute this. And we see we no longer have any categorical columns in the categorical data frame, but we have a few categorical columns in the original data frame, which makes sense because we didn't cleanse them in the original data frame. So I'm going to go ahead and drop the categorical columns from the original data frame and put it in a new data frame called numerical data frame, and then check for any remaining categorical columns in the numerical data frame and print them. So let's go ahead and execute this. And we see there are no categorical columns. We still have 171 records and 8 columns in the numerical data frame, which all have data types of int or float. Now I'm going to combine the numerical data frame and the categorical data frames into a single data frame named data frame. To do that, I'll call the concat method on pandas, passing the numerical data frame and the categorical data frame, setting the axis to 1 for the x-axis. Now we see we have 23 columns, all of which have numerical data types. And finally, I'm going to save that data frame to a CSV file, passing it the file name for the CSV, setting index to true, so each row will have an index, and excluding the header. So first, let's jump back over to our home page in Jupyter Notebook, and we see we don't have the data CSV. So now we'll run the cell, jump back to the home, refresh, and we have our CSV with numerical values. Okay, now that we have the cleansed data in a CSV file, what I want to do is copy that CSV file from the current working directory into the MySQL directory on my machine, because this is the default location MySQL will load files from. Then I'll just print out the contents of the MySQL database data.csv file to make sure it was copied over. And here we see the file. Now, when working with MySQL, we'll have to provide the host name, the username, and the user password. I've stored these in environment variables on my machine instead of hard coding them. But again, since I'm assuming you have some experience with MySQL, I'm sure you know how to handle this. So the first thing I'm going to do is read those environment variables and populate the host, user, and password variables, and then establish a connection to the database. Now I'm going to scroll down and execute this cell, and we'll see an exception that we can't connect to the MySQL server. And that's because I haven't yet started the database. So let me go ahead and do that. Okay, now I'll launch MySQL Workbench. And we see the only schema I have is a sys schema. So let's jump back into Jupyter and get ready to execute this cell again. So now that I have the database started, I can go ahead and create a SQL connection using the MySQL connector we imported. And then if the database is connected, I'll create a cursor which will be used to interact with the database via SQL queries. So the first thing I'm going to do is execute the query to show the databases that are like cleansed automobile data, and then call fetch1 on the cursor, storing the result in the DB exists variable. If the database exists, I'll print a message that the cleansed automobile database already exists. If it doesn't exist, I'll execute the command to create the database, then use the database, and then take this SQL string that I've created to create the automobile data table and pass it into the execute method on the cursor. Then I'll describe the table and then create a string to load the data from a file named data.csv into the automobile data table in the cleansed automobile data database. I'll specify that the fields are terminated by commas in the CSV, indicate that strings are optionally enclosed by a double quote, and that the lines are terminated by a new line terminator. And finally, ignore the first row to exclude the header. Now I'll go ahead and execute the command and commit the changes. Then finally, I'll execute a command to select the count from the table, grabbing the count from the cursor execution result, and then printing the result. So let's go ahead and execute this now. Here we see that the MySQL connection was successfully established, that the database does not exist. So I'm creating it, and it was created successfully. Here's the table structure that was created, and there are 170 rows in the table. And finally, I close the cursor, which we see here. So let's jump back into MySQL Workbench real quick, do a refresh. Here's our database, the table with the columns, and if we do a select, we see our data. Okay, to wrap this up, I'm going to execute a statement against the database to select everything from the automobile data table and store it into a Pandas data frame. I'll drop the ID column from the data frame and then print the info, head, and describe. So let's go ahead and execute this. And here we see our new data frame with 170 rows, 23 columns, the data in the columns, and summary statistics. So that concludes this video on loading, cleansing, and persisting data using NumPy and Pandas. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.